In this video, we will solve problems from exercise 3.4. Question number 1. If sin x is equal to 15 by 17 and cos y is equal to 12 by 13 and x ranges between 0 to pi by 2 and y ranges between 0 to pi by 2, find the value of sin x plus y, cos x minus y, tan x plus y. So first let's try and get all the values of sin x, cos x, sin y. Cos y is already given. Then we can also get tan x and tan y. So let's use sin x first. Sin x is equal to 15 by 17. So let's consider this right angle triangle A, B, C, and let this be the angle x. Then your sin x is 15 opposite side, which is AB, by hypotenuse, which is AC. Therefore, in triangle ABC, the side BC is equal to root of 17 squared minus 15 squared. So solving this is nothing but root of 17 square is 289 minus 225, which is equal to root of 64, which is 8. So we have BC as 8. We found this. Now let's take our cos y. So cos y is equal to 12 by 13. Therefore, in triangle PQR, let us, our cos y, this is angle y, will be, the adjacent side will be 12 and our hypotenuse will be 13. Therefore, in triangle PQR, PQ will be equal to square root of 13 squared minus 12 squared, which is equal to root of 169 minus 144, which is equal to root of 25. That's equal to 5. Next, let's find our cos x. We have our sin as already, sin x as 15 by 17. So our cos x using the first right angle triangle would be 8 adjacent side by hypotenuse, which is 17, and our tan x will be opposite side by adjacent side, which will be 15 by 8. Similarly, in triangle PQR, we found PQ to be 5. So our sin y will be equal to 5 by 13 and tan y will be equal to 5 by 12. So now let's solve the first part of the question, which is sin x plus y. So sin x plus y we know is equal to sin x cos y plus cos x sin y. So let's substitute the values of sin x cos y, cos x sin y. Cos x is 15 by 17, which is given, and our cos y is 12 by 13, again it's given, plus our cos x is 8 by 17 and our sin y is 5 by 13. So simplifying this, the denominator will be 17 into 13, 15 into 12 will be equal to 180 plus 40, that's equal to 220 divided by 17 into 13 is 221. The second part of the question, which is cos x minus y. Cos x minus y, the formula is cos x cos y plus sin x sin That's nothing but our cos x is 8 by 17 into cos y is 12 by 13 plus sin x is 15 by 17 and sin y is 5 by 13. So further simplifying this again, the denominator would be 17 into 13 and 8 times 12 is 96 plus 15 times 5 is 75. So the answer is 171 divided by 221. Then the third part of the question, which is tan x plus y. The formula is tan x plus tan y divided by 1 minus tan x tan y. So applying the values, so tan x is 15 by 8 plus tan y is 5 by 12 divided by 1 minus 15 by 8 into 5 by 12. So simplifying this further, we can, let's keep the denominator as, in the numerator, 8 into 12. So this becomes 180 plus 40 divided by, again, making 8 into 12 as the common denominator. In the denominator, you get a 8 into 12 minus 15 times 15 will be 75. So your denominators of the numerator and the denominator will disappear. So you're left with 220 divided by 8 times 12, which is 96 minus 75. So the answer is 220 divided by 21. Question number 2. If sin A is equal to 3 by 5 and cos B is equal to 9 by 41 and A lies in the interval 0 to pi by 2, which is the first quadrant, and B lies in 0 to pi by 2, which is the first quadrant again, find the value of sin A plus B and cos A minus B. So given to us, sin A is equal to 3 by 5. So let's consider this triangle PQR and let this angle be A. Then PQ would be 3 and the hypotenuse would be 5. Therefore, our QR will be equal to square root of 5 squared minus 3 squared, which is root of 25 minus 9, that's root of 16, that's equal to 4. So QR is 4. Similarly, what is given to us is that cos B is equal to 9 by 41. So let's again consider this triangle here as, let's say, P1, Q1, R1 and cos B. So the angle here is B. Now cos B is adjacent side, which is Q1 R1, 9 divided by the hypotenuse P1 R1. Therefore, our P1 Q1 is equal to square root of 41 squared minus 9 squared. And we can rewrite this as A squared minus B squared. So 41 plus 9 into 41 minus 9. So that will be equal to square root of 50 into 32. So further, if you make this 16 into 2 and make the 50 as 100, this becomes 100 into 16, which is nothing but root of 10 squared into 4 squared. So your answer would be 40. So your P1 Q1 is 40. Now let's find our cos B. Sorry, cos A. Cos A will be equal to, from the first triangle PQR, adjacent side which is 4 by 5. So that will be 4 by 5. And our sine B from the second triangle here, P1 Q1 R1, would be opposite side 40 by 41. 40 divided by 41. So now to the first part of the question, which is sine A plus B. So sine A plus B is equal to sine A cos B plus cos A sine B. So that's equal to, substituting the values of sine A cos B. Sine A is 3 by 5 and cos B is 9 by 41 plus cos A is 4 by 5 into sine B is 40 by 41. So that's equal to, your denominator will be 205, which is 5 into 41. It's the same for both the terms. Then this is 27 plus 160. So your answer will be 187 divided by 205. Then the second part of the question, which is cos A minus B. Cos A minus B, the formula is cos A cos B plus sine A sine B. Again, substituting the values, cos A is 4 by 5 and cos B is 9 by 41 plus sine A is 3 by 5, 41 here, into sine B is 40 by 41. So the denominator again will be 205 and this is 36 plus 120. So the answer is 156 divided by 205. Question number 3. Find cos x minus y given that cos x is equal to minus 4 by 5 with x ranging from pi to 3 pi by 2 and sine y is equal to minus 24 by 25 with the y ranging from pi to 3 pi by 2. So which means both x and y are in the third quadrant. So given to us cos x is equal to minus 4 by 5. So let's consider this triangle here, A, B and C. Now since cos x is equal to minus 4 by 5, the adjacent side would be 4 and the hypotenuse would be 5. Therefore, AB will be equal to square root of AC squared minus BC squared. That's equal to root of 5 squared minus 4 squared, which would be equal to root of 9, which is 3. So 3 would be AB. Next, sine y is equal to minus 24 by 25. So let's define this as P, Q and R, right angle triangle. Here the angle is X and here the angle is Y. Now sine Y is 24 minus 24 by 25. That means opposite side is 24 and the hypotenuse is 25. Therefore, QR will be equal to root of PR squared minus PQ squared. That's equal to root of 25 squared minus 24 squared. That's equal to root of 625 minus 576, which is equal to root of 49, and that would be 7. Therefore, our QR is 7. So now let's find sine x using the triangle ABC. So sine x will be equal to opposite side, which is 3 over 5, and because x is in the third quadrant, sine will be negative, so the answer would be minus 3 by 5. Similarly, our cos x is also given to us as minus 4 by 5. Then we already have sine y as minus 24 by 25. Then cos y will be using the triangle PQR. Since cos is in the third quadrant, y is in the third quadrant, cos will be negative. So adjacent side, which is minus 7 by 25. Now we are asked to find cos x minus y. So that will be equal to cos x cos y plus sin x sin y. And that's equal to cos x is minus 4 by 5 into cos y is minus 7 by 25 plus sin x is minus 3 by 5 into sin y is minus 24 by 25. So further, taking the common denominator as 5 into 25, the numerator here would be minus into minus is plus, 4 sevens are 28, plus minus into minus will be plus again, 3 times 24 will be 72. So that is equal to 100 divided by 125. So the answer is 4 by 5. Question number 4. Find sine x minus y, given that sine x is equal to 8 by 17 with x ranging from 0 to pi by 2 and cos y is equal to minus 24 by 25 with y ranging from pi to 3 pi by 2. So our x is in the first quadrant, so let's define this as our x, and our y is in the third quadrant, so let's define this angle as y. Okay, so given to us sine x is equal to 8 by 17. So since sine x is 8 by 17, the opposite side will be 8 and the hypotenuse will be 17. Let's define this as A, B and C. Therefore, the length BC is equal to root of AC squared minus AB squared. So that's equal to root of 17 squared minus 8 squared, and that's equal to, you can rewrite this as 17 plus 8 into 17 minus 8, which is equal to root of 25 times 9, which is nothing but 5 times 3, so answer would be 15. Similarly, we have our cos y equal to minus 24 by 25. Now, let's define this as our right angle triangle P, Q and R, and cos y is minus 24 by 25, so the adjacent side is 24 and the hypotenuse is 25. So from here, our PQ is equal to root of 25 squared minus 24 squared, which is equal to root of 49, which will be 7. So our PQ here is 7, and we found our BC to be 50. So now our cos x will be equal to adjacent side by hypotenuse, which is 15 divided by 17, and our sine y will be equal to opposite side, which is, and because it is in the third quadrant, it will be also negative, so 7 divided by 25. Now what we are asked to find is sine x minus y. So sine x minus y is equal to, the formula for this is sine x cos y minus cos x sine y. So substituting the values of sine x cos y and cos x sine y, we have 8 by 17 into cos y is minus 24 by 25 minus cos x is 15 by 17 into sine y is minus 7 by 25. So further, this would be in the denominator 17 into 25, and the numerator would be here minus 192 plus 105. So the answer would be minus 87 divided by 425. Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.